Hi everyone, today we are talking about scientific notation word problems. As a reminder, you do not need to write down everything, but be sure to jot down important information and at least one example of each type of problem that we cover. Remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward too much that you miss out on something important. So let's begin. For scientific notation word problems, just like any type of word problems, what you do need to pay attention to is your keywords and phrases, and obviously know how to add, subtract, multiply, and divide by scientific notation. What I have here are some keywords and phrases for adding, subtracting, multiplying, and dividing, so make sure that you pause the video and jot these down. For add, if your problem has a key phrase altogether, combined, or how many total, it might trigger you to think that you might need to add for this problem. But be careful because multiply could also use similar words like that, like altogether or combined, and total. Because multiplication is when you have a group that's being multiplied several times to get to a total. So just be careful. Sometimes people get adding words mixed up with multiplying words. Multiply words are also like how many times can something fit in one. So you really will need to understand what the question is asking you and not just look for keywords and phrases. Similarly, subtract and divide have a lot of overlap. So subtract will usually ask how much more of one item is compared to another item, or how much greater is one item compared to another item. With divide, they could also ask how much more, but it's specifically how many times more. How many times can something fit in one? And also how many of something per another something, like kilometers per hour, like speed, where you divide. So again, add and multiply, those words have overlaps. Subtract and divide have a lot of overlaps as well. What you do need to pay attention to is what exactly that problem is asking you, since there is so much overlap. So we're going to go through some examples today. For this problem, it says that the volume of the Atlantic Ocean is about 3.1 times 10 to the 17 cubic meters. The Mississippi River has an annual flow of 6.3 times 10 to the 11th cubic meters. How many times will the annual flow of the Mississippi River fit in the Atlantic Ocean? Write your final answer in scientific notation and round to 2 decimal places, so only 2 digits behind the decimal point. Go ahead and pause the video and first decide which operation is this, add, subtract, multiply, or divide, and then try the problem out on your own. Okay, so with this problem, I am going to draw myself a picture because that'll help me visualize things. So first I have the Atlantic Ocean. It's huge. It's an ocean. And it is about 3.1 times 10 to the 17th cubic meters. And then I have the Mississippi River. So that's going to be smaller because it's just a river. It's a big river, but it's not as big as the Atlantic Ocean. And it has an annual flow of 6.3 times 10 to the 11th cubic meters. Even though 6.3 is bigger than 3.1, right? 6 is bigger than 3. This is a smaller number because of the power. 11th power compared to 17th power, 1 is smaller, and that is the 11. 11 is smaller than 17. So there's a reason why they're called powers, because they have more power. The 6.3 is just the digits, and then the 11th power versus the 17th power tells you how many place values. This one has 11 place values. And while this one has much more zeros behind that number, it has 17 place values. So they want to know how many times will the Mississippi River's flow fit inside of the Atlantic Ocean. How many times? So be careful, times could mean multiply or divide. So you're going to have to decide, is this a case for multiplying or dividing? Just because it says times doesn't mean it's automatically multiplying. Okay? We say times in math a lot, like 3 times 4, or 5 times 8. Those are two numbers multiplying by each other. But here they want to know how many of the Mississippi rivers will fit inside of the Atlantic Ocean. You could fit 1, 2, 3, 4, right? We just don't know that number, how many of them will fit inside. Just like if we had a box that can fit 10, and then we have objects that are 2. How many of those 2's can fit inside? That would be 5, right? So I'm drawing out an example with smaller numbers to kind of help me visualize it. If my big amount can fit 10 and my small amounts are 2, how many of those 2's can fit inside? I'm really taking that big amount 10 and I'm dividing by 2 to get 5. So in this situation with these bigger numbers, it's the same thing. My ocean is 3.1 times 10 to the 17th power, and I need to divide that into all these little Mississippi rivers. So I'm dividing it by 6.3 times 10 to the 11th power. So this problem is a division problem, even though it says the word times, because they want to know how many times they will fit in there. So you're looking for a smaller number. If we were to multiply, we would get a much bigger number. And it also wouldn't make sense why you would multiply them to get how many times it would fit. Okay? So if you said division, then you are correct. And let's go ahead and solve this. If you haven't solved it yet, go ahead and pause the video and solve it on your own before I give away the answer. So if you remember from before, with multiplying and dividing, you are going to use normal multiplication and division for your first numbers and your shortcut for your exponents. So this becomes whatever 3.1 divided by 6.3 is. And remember they said to round to the nearest 2 decimal places. So this is going to round to 0.49. 0.49. Let me get some more room here. So 0.49 when we divided these two, multiplied by 10 to the, this is subtraction now because it's division, 17 minus 11 is 6, so it's 10 to the 6th power. 0.49 times 10 to the 6th power. Almost there because this is not quite in scientific notation. We want to move it over so that we have only one digit in front of the decimal place, one non-zero digit, so it becomes 4.9. But then we have to change something here. We move this one forward 1, so we're going to have to move this one back 1. So it'll be times 10 to the 5th power. We have to balance it out. If we move this one forward, then we got to move this one backwards. So it should be 4.9 times 10 to the 5th power times. So it's a really big number. 10 to the 5th power would be like 4 zeros in the back. So this is 490,000 times that it would take for the Mississippi River to fit into the Atlantic Ocean. So the reason why that didn't work was our 4.9 didn't have 2 decimal places behind the decimal number, so we needed to put in that 2 there since we moved it back. So it should be 4.92. We only had 1 decimal place, so we need to put that 2 back in there. 4.92. So we got rid of one of the decimal places. We need to put that back in there. There we go. All right. A little minor error. We had 2 decimal places, but then we lost it when we moved it over, so we needed to look at our calculator for the answer. It had that 2 in there, so we need to put that back in. Okay, minor issue. No big deal. Now you know when you're working on this kind of stuff. You don't want to have that silly error like me. I got so excited about the 2 decimal places that I didn't check it again when I submitted the final answer. Let's do another example. In this problem, it says the annual expenditure of the U.S. federal government is approximately $4 trillion. That's for the U.S. federal government. That's how much they spend, expenditure, every year. If $1 bill is 0.0001 meters thick, how many meters tall would a stack of 4 trillion $1 bills be? A stack of 4 trillion $1 bills. So that means that you need to, okay, and it says for reference, 1 trillion equals 10 to the 12th power. That was very important. If we didn't have that, we wouldn't know what the power of 10 is. So go ahead and pause the video, see if you can figure out the operation, add, subtract, multiply, or divide, and then try this problem on your own. All right, so the U.S. spends $4 trillion. Let's go ahead and change that to 4 times 10 to the 12th power first. And then they said $1 bill, let's change that to its power, is 1, 2, 3, 4 to make it into 1. So 1 times 10 to the 4th power. How many meters tall will a stack of 4 trillion $1 bills be? So each of them is this, and 1 times 10 to the 4th power. Oh, sorry, negative 4th power. Ooh, I almost made that positive. That would have been a very thick dollar bill. This is a decimal number, so it's got to be a negative power. So if you said that you need to multiply, you are correct, because each of them is 1 times 10 to the negative 4th power. We need to look at how thick that stack would be if we multiplied that 4 trillion times, because there are $4 trillion, okay? Just like if there were 2 of them, you would take this number and multiply by 2. If there were 3 of them, you would take that number and multiply by 3, because there's 3 of them. Well, now we're saying that there's 4 trillion of them. So we are taking 1 times 10 to the negative 4th power and multiplying it by 4 times 10 to the 12th power. We know from previous lessons that we need to do normal math for our first part, so that's 1 times 4, which is 4. And we need to use our shortcut for our powers. They're multiplied, so we need to add them together. Negative 4 plus 12 is positive 8. So this should be 4 times 10 to the 8th power meters. Because we want to see that thickness for the dollar bill 4 trillion times. So that's why we multiplied it. All right. One last problem. In this problem, it says the diameter of a human hair is 9 times 10 to the negative 5th meters, negative 5th power meters. The diameter of a spider's silk is 3 times 10 to the negative 6th power meters. How much greater is the diameter of the human hair than the diameter of a spider's silk? Write your answer in scientific notation. Pause the video and figure out what the operation is first, add, subtract, multiply, or divide, and then try it on your own. Okay, I see how much greater. Remember, subtract and divide have how much greater, right? But divide says how many times greater. This one doesn't have that, so it's just subtraction. If you said subtract, then you were on the right track. Which one is bigger? Let's see, how much greater is the diameter of the human hair than the diameter of a spider silk. So it looks like diameter of the human hair is greater because they want to know how much greater it is compared to the spider silk. So we're going to take 9 times 10 to the negative 5th power, subtract 3 times 10 to the negative 6th power. This is a subtraction problem. Subtraction and addition, we need to line up our powers. So that means our powers have to match. So I'm going to take this negative 6th power, which is smaller, and I'm going to add 1, so it matches and becomes negative 5th. So that means I'm moving it to the right to make it bigger. So that means here I need to move to the left to make it smaller. So we want to balance it out. We can't just change one and not the other. So this becomes 9 times 10 to the negative 5th power minus 0.3 times 10, now also to the negative 5th power. We wanted them to match up with power so that we can just copy it back down. Those zeros match up. And we're going to subtract 9 minus 0.3, so we should get 8.7. So our answer is 8.7 times 10 to the negative 5th power. Okay, double check my work really quick. Same power. We added 1 to get to negative 5, so that means we move back 1. And that's correct. Okay, so be careful. Make sure you check your work before you submit and read those directions carefully. Make sure that if you need to draw out anything to help you understand the problem, do that. Let me know if you have any questions as you work on these, and if not, I will see you in class.